how are you today? You're welcome. Hello everyone, welcome to today's class. All right, so I am supposed to teach you another topic, but I realized in this last concluded exam, a lot of you did not do very well to my satisfaction. So I saw some lapses, I saw some questions that were unanswered. So I needed to know why the problem is. As I brought this past question, especially the theory part, some of you do not understand what they mean by that. The theory part, especially the calculation part of it, even the dimension, we do not do it very well. So I decided to use today to do a review or to do a revision on the past exam question, okay? Because you're going to be expecting it in your subsequent exam, so you don't make the same mistake you made previously, okay? That's what I'm going to do. You're going to do revision, so by tomorrow you're going to start a fresh topic. So I will clear all your doubts. I hope that is okay. All right, so I will start with the theory part. Then after that, I'll look at some OBJ questions that you find it difficult. Then we can start with that. All right. If you are just joining us, give it a thumbs up, okay? Now you are welcome. So let's proceed. Just make sure you like this live stream. Hope you all can hear me. All right. All right, so number 1A question, the theory part. Like I said, I'm going to start with the theory. You have to state the dimension of the following, but the first one given is stress. So what is stress? What is stress? They even gave us how to generate our stress, or the formula for stress. They say that stress is force multiplied by what? Area, right? Now we are going to use this to get the units of stress and also get the dimension of stress. Now let's go. Now, if you say that stress is force over area. Now, what is force? My force is what? Mass times acceleration, right? So this is mass times A, okay, divided by area. Now the next thing you're going to, what's the unit of mass? Unit of mass is what? Kilogram multiplied by, what's the unit of acceleration? Unit of acceleration is what? Meter per second square. I have meter per second square, okay? What's the unit of area? Unit of area is meter, right? Now, if I decide to carry this up, remember it is the denominator. A lot of indices that say A over B. This B have invisible power of 1, and this A equally have invisible power of 1. Now, if I want to carry it up, it's going to be have a negative sign by saying that this is AB minus 1. Is that clear? All right. So going by that, I have to multiply. I'm looking for the unit now. Now I have kilogram meter per second square. That is what I have, okay? Now this meter square that is the denominator, I'm going to carry it up to have a negative sign because it's in the denominator and I want it to be in the numerator. I'll now say multiply by m minus 2. Is that clear? All right. Now this meter already have power of what? 1. So what am I going to do? From the lot of indices, I have meter here, I have meter here, right? I'm going to take one of the meter, that is, take one of the bases and add the powers. So this will be kilogram, this is meter 1 times meter minus 2. Is that clear? Then I'll now put the second square, right? Now I've brought both of them together. The next thing I'm going to do is to work on the powers. Now this is kilogram meter, this is 1, this is minus 2, right? So I have 1 minus 2 per second square. Is that clear? Then eventually I'm going to have what? I'm going to have kilogram meter, 1 minus 2 is what? Minus, I have minus 1, then per second square. This is unit of stress. Is that okay? Now for me to get the dimension of stress, remember that the three quantities used for dimension, they are mass, length, and time, okay? Because they are very important part of the fundamental quantities. Now, if you see kilogram, is measurement for mass. So you are just going to write capital what? M, right? Now, if you see meter, is measurement for what? For length. Just going to write capital L, power what? Minus 1. Then if you see seconds, is measurement for time. You're just going to write capital T, power what? Minus 2. M, L power minus 1, T power minus 2. Is that clear? Hope you get it now. Right. Okay, Prevail, you're welcome. Please do what I just said now. I explain. Do you understand? Do you understand? Kewe, Naomi, prevail. Christina, okay? So you can chat me up on WhatsApp, so I will add you. All right. So number AII, we have the next question. AII, you're asked to find the energy. Energy, okay? Then in the perpendicular distance, I can say in quotes, energy is force multiplied by what? Distance. Okay, so how do we solve this? How do we get the dimension of this energy? The first thing you're going to do is to get the dimension, the formula for work. Sorry, for force, they multiply by that of distance. Okay, so let's go. Energy. What's my force? Force is mass times acceleration, then multiply by distance. Is that okay? So let's go. What's the unit of mass? Unit of mass is kilogram. Multiplied by unit of acceleration is meters per second square. Multiplied by unit of distance is meter. Now, can we bring it together? Look at this. We have kilogram multiplied by meters per second square multiplied by meters. Now, we have from the law of indices, this one have a power of 1 and 1, right? Let's bring them together by saying this is kilogram, meter multiplied by meter. This is power 1, right? Then multiplied by second square. Now, I'm going to use the law of indices to add these two together. Okay, this is kilogram meter power 1 plus 1, then per second square, right? Then I'll come to a conclusion that this becomes kilogram meter 1 plus 1 is what? 2 per second square, right? Now this is the unit of energy. This is the unit of energy. For us to get the dimension, you must remember these three things. I've said this earlier: mass, length, and time, okay? Because you need to get the dimension. All right, so let's go. The dimension of energy becomes kilogram is for mass. We're going to write capital M. Meter is for length. We're going to write capital L power what? 2, okay? Then seconds is for time. We're going to write capital T power minus 2. So this becomes the dimension of energy, which is ml squared T power minus 2. Is that clear? Now remember that energy and work, they have the same x. If you have this as energy, it's still going to go for what? For work. Is that clear? All right, copy. Christiana, please, can you type in your WhatsApp number? I will add you after this class, okay? Just type it now. Let me just get it. I will add you. All right. Are we all clear? Do we understand? Kewe, Prevail, Christiana, is that cleared? All right. Copy fast. I have a few minutes to go. All right. Are we all cleared? Okay, let's go to the next one. We have momentum, we have impulse, we have pressure. All right, let's move to the next one. right, so the next thing we are going to look at is momentum. Now, what is momentum? Momentum is defined as mass times velocity, okay? Now, you can just say mass times what? Velocity, right? Now, what's the unit of mass? Unit of mass is kilogram. Our unit of velocity is meters per second. Is that clear? Now, let's just bring it together to get the units of momentum by saying that this is kilogram meters per second, right? Now, can we get the dimension? This is the unit of momentum, okay? Can we get the dimension? Saying this is what? MLT power minus 1. Is that clear? Now, this is the dimension of what? Of momentum. That is MLT power minus 1. Right. So the next we are going to look at is impulse. Impulse. Impulse, this is where a lot of majority of you people make a lot of mistake. Impulse is equals to force multiplied by time. But I saw some persons writing force over area. So whatever thing they solve, they got it all wrong. So let's go. The symbol for impulse is I. So what is the unit of force? Unit of force is kilogram meters per second square, right? I'll multiply by time, which is measured in what? In seconds. Okay? Now, these seconds have invisible power of 1. I'm going to bring it together to sum it up with a lot of indices, and this becomes kilogram meter per second square multiplied by per second, right? And that gives rise to what? This becomes kilogram meter. Remember, I have second and second, right? And seconds per minus 2. Sorry, this is 1, not minus 1. This is 1, okay? Then plus what? 1, right? So what do I have? Then I'll have again that the units of impulse becomes kilogram meters per second. Is that clear? Impulse is what? Kilogram meter per second. That is the unit of impulse. Unit of impulse. So for us to get the dimension of impulse, what do? Kilogram is for mass, meter is for length, and seconds is for what? Time, right? Seconds is for time, right? So if you are comparing this with another quantity, or you have to find the values of power x, A, B, and C, you can equate this to what you have and get the constant. Is that clear? Now, this is how we are able to get the units of momentum and the dimension of momentum, and that of impulse and is this, that you must know the definition of any quantity. It will enable you to get the dimension. Now, looking at what I have, you can see that the unit of impulse with momentum is the same, right? It's the same. So if you know that these things, they work together, you can easily generate them. So if the unit is the same, that means look at the dimension of momentum and that of what? Do you understand? Right. Robin, you're having network issues. You can off your data and on it again, okay? You can check where the error is coming from. You can change your location and see what you have. Please, if you are just coming stream, okay? Just explain. Nakuzi Onyeka, thank you so much for coming. Robinson, Christiana, Eze, Kewe, do you understand? Prevail, do you understand? Ukamaka, do you understand? All right, I'll move to the next one. Christiana, just send your WhatsApp number. Type your WhatsApp number now. Let me add you after the class. Just type your WhatsApp number right now. Let me add you after the class. Yes, contact me after now, okay? Okay, I should explain again. All right, so looking at what I have, we have momentum, okay? We are asked to get the dimension of momentum. Before we can get the dimension of momentum, the examiner even went ahead to tell you that momentum is mass multiplied by what? To be able to do that. Now, I said that momentum is equal to mass times V, right? So what's the unit of mass? Unit of mass is kilogram. And unit of velocity is meters per what? Second. Unit of velocity is meters per what? Second. Okay. Now it will now generate this to have our unit of momentum to be kilogram meters per what? Second. Okay. Now with that being said, we now move into what? Dimension. This is kilogram, unit for mass. We're going to write capital M. This is mass, unit for letter. We're going to L. And this is time, unit for what? This is seconds, units for time. We're going to write capital T. I will now put back the power. That makes the unit of momentum, the dimension of momentum to be what? MLT power minus 1. Is that clear? All right. For the impulse, impulse is force multiplied by what? Time. Now, impulse, what's the unit of force? Kilogram meters per second square. Okay? Multiplied by time, which is second. Right? Okay. So, what you're going to do, because we have second here and we have second here. So, what you're going to do is to work on the powers. Okay? Now, this is kilogram meter. This is per second square, and this is what? Second. This one have invisible power of 1, while this is power minus 2. Let's bring them together with the law of indices because the bases are the same, which is second and second. Okay? Now, impulse equals to kilogram meter second. This is power minus 2 plus 1. I brought these two together. It gave rise to kilogram meter per what? Second, which is the same thing as the unit of momentum. Now, for us to get the dimension, kilogram is unit for what? Mass. Meter is unit for what? Length. And seconds is unit for what? Time. So we have meets MLT power minus 1. Is that clear? All right. Robinson, do you understand? All right, let's move to the next one. Kingsley, as I say, some part is not showing. Are you seeing it now? Is it clear now? All right. So let's look at this question. At what respective values of A, B, and C would the units of impulse equivalent be dimensionally equivalent to m power minus a L power minus B and T power minus what? C. Is that okay? All right. So for us to be able to solve this, you must go back to derive the dimension of what? Impulse, right? If you're able to do that, we equate it with this and be able to find the powers, which is A, B, and C. They are just constant, so we're supposed to solve for them. All right. So what we just solved for impulse right now, my impulse is, I can say, let me start again, force times time, and the force is kilogram, let me solve it again, kilogram meters per second square multiplied by second, right? Then I bring it together by saying that this is kilogram meter x minus 2 plus 1. Okay, I just solved it fast, so that's why I'm like rushing it. So this gives rise to what? Kilogram meters per second, right? As the unit of impulse. Now, what do we do next? I have to equate it with what I have. This is kilogram meter per second. For me to get the dimension, I have the dimension to be what? Kilogram is for mass. I have mass. Meter is for length. Seconds is for time. So the dimension of impulse is mLt power minus 1. Now I'm going to equate it with the constants given, right? So I will say mLt power minus 1, right? The m, which is for meter, has power of, which is kilogram, sorry, has power of 1. Why this have power of 1, okay? So I equate it to m power A, L power B, and T power C, right? Now looking at, I can just bring it together. Now, if I say M power 1 is equals to M power A, right? Then if I cancel this, automatically A is equals to what? 1. Is that clear? The same thing is applicable. Power 1 is equals to L power B, right? If I cancel this, automatically B is equals to what? 1. Is that clear? Now, T power minus 1 is equals to T power C. If I cancel this, automatically C is equals to what? Minus 1. Is that clear? So therefore, my A is equals to 1, my B is equals to 1, while my C is equals to minus 1. So the constant A, B, and C is what we have gotten using the dimension of what? Impulse. Is that clear? I hope you understand that. Okay. All right, please, can you get it? Do you understand what I just explained? I want to move to the main one that is more important. We can solve together. Is that clear? Kewe Robinson. All right, so Let's look at this question. All right. I want you to copy the question. Copy the questions. I'm going to solve it so you can have the questions. When I start solving, you understand what I'm solving, okay? You have few seconds to do that. Just copy the question first. Let us start solving. Okay. All right, please, are we done? Okay, let's solve together. All right, so let's solve what we have from what you just wrote down. Okay, so they say your network is bad. Okay, so sorry. You can check your location. We change your position, see whether it's better. Now, from what we just wrote, let's solve together. This question 3 in your exam. This question 3, okay? It says, a car starts from rest and accelerates uniformly for 5 seconds until it attains a velocity of 30 meters per second. It then travels with uniform velocity for 15 seconds before decelerating uniformly to rest in 10 seconds. Sketch a graph of the motion. All right, so what we are going to do, the first step is to sketch the graph. Now, this is a velocity time graph. Okay. All right, so this is velocity and time. Now, this is 0. So let's start again. A car starts from rest. That means the car started from here, which is rest, and accelerates uniformly for 5 seconds. So let's go this way. For what? For 5 seconds. Okay? Until it attains a velocity of 30 meters per second. This is velocity axis. This is 30. Okay? It then travels with uniform velocity for 15 seconds. So it maintains this speed for 15 seconds. So it goes this way. This is uniform velocity for 15 seconds. Now, we are not going to write 15 here. We are going to add 50 to give us 20, okay? So the difference between this and this is going to give us 15, right? That is how we do it. Now, this is what? 15 plus 5 is going to give me what? 20. Is that clear? Because this body maintains this speed for 15 seconds. If I put 15 seconds here, that means the difference between this and where the speed was maintained becomes 10. But by the time I add this 5 to 15, making it 20, that difference will be 15. Is that clear? All right. It then travels with uniform velocity, for 15 seconds before decelerating to rest in 10 seconds. Now it goes down to rest from here. Rest means going down to 0. Okay. In how many seconds? In 10 seconds. Okay. Now 10 plus 20 is going to give me 30. Do you understand this question now? If they say a body start from here, it's going to start from here to move. At a certain time, you know this, right? And at a certain velocity, you know the velocity and velocity axis. Okay? Then if they say it maintains that speed, you do not maintain this speed going straight, that is uniform velocity. Until a certain time, that is the time axis. Right? You're going to add the difference here to get the difference you are given. Okay. Now we are done sketching the graph of the motion. The next thing to do is to use the graph below to calculate the acceleration during the first 5 seconds, That is from here to here. We have to calculate the acceleration. Now, what do? We are going to label this to enable us solve what you're looking for. This is A, B, C, D, and E. Is that okay? Now, acceleration is this line A what? Sorry, O what? A. This line OA becomes my acceleration. Why this line BC becomes my what? Deceleration. Okay? So for me to get acceleration during the first 5 seconds, that is from here to here, right? So I'm looking for acceleration, which is line what? OA. Do you understand? And acceleration is equal to change in velocity over change in time. What's the change in velocity? AE. Vertical, remember vertical is for velocity, horizontal is for time. So that is AE divided by what? EO. Is that clear? I hope you are still following me. Okay. Christian, said the board is not clear. Is it clearer now? Can you see it's clearer now? All right. Now I'm going by what we have. What is my AE? My AE is vertical. That is velocity. I will go outside here and pick the values of what I have. My A on the vertical is 30, while my E on the vertical is 0. Don't get it confused. My A on the vertical is 30, my E the vertical is what? 0. If I say velocity, so I'll come outside here and pick the value. So A here is 30, while E here is 0. So I'm going to have 30 minus 0. Okay? Right. Then here, I have my EO. My E here is what? 5, while my O here is what? 0. Is that clear? Change in velocity over change in what? Time. So this is 5 minus 0. Do we understand? Okay, so let's subtract. 30 minus 0 give us 30. 5 minus 0 is going to give us what? 5, right? So by the time we divide it, my acceleration A becomes what? 6 meters per second square. Is that clear? I hope you understand. Do we have question? You can ask your question if you have. Okay, so I should explain again. All right, I'll do just that. Okay, let me see. After sketching the diagram with the question given, and I'm asked to find the acceleration during the first 5 seconds, what I'm going to do is to label it. I label it this way: A, B, C, D, and E. Right? So the next thing I'm going to do, because I'm looking for acceleration, and this line OA is acceleration, while the line BC becomes what? Deceleration. So as the body okay, that is what you're looking for. So you're looking for acceleration, which is what? Line OA. Now this is just like this covering this. This is a triangle, right? This is a triangle. Now this is A, E, and what? O, right? And this is given as 30, while this is what? 0, right? That is for the vertical. Then for the horizontal, this is given as what? 5, and this is also what? 0. So this is what I just have. Sorry. And I'm looking for what? Acceleration. So acceleration is change in velocity over change. I just brought it out from this graph so you can understand better. Change in velocity over change in time. Then my change in velocity here is what? AE. AE. Can you see it now? AE, right? Okay. Then my change in time becomes EO. That is EO from here to here, right? Okay, so what do I have? So my A here becomes 30 minus what? 0. You'll be like, how do we have 0 here and we equally have 5 here? When you are considering the vertical, which is the velocity, we are not considering this. This is just like vertical outside, okay? This A outside 30. Outside here, E is what? 0. This is what I'm considering. I just brought it outside, and this is the value. So for the vertical, A becomes 30 and E becomes what? 0 on the vertical, because vertical is for velocity, while horizontal is for time. Okay? Is that clear? So I just substituted the value by saying my A is 30, my E is 0. So that is difference between them. 30 minus 0 divided by what? 5 minus 0. Is that clear? Now when I subtracted, I got 30 over 5 and my answer becomes 6 meters per second square. Is that clear? Right. Christina, is that clear? Do you understand better now? Kebe, are we still there? Prevail, Ezekiel, are we still there? Do we understand? So I can move to the next question. All right. Good. All right, let's move to the next one. The next question says you should calculate the deceleration during the last 10 seconds. So the deceleration during the last 10 seconds is from here to here, okay? So you're looking for you understand? So in deceleration, we are covering this. This is a triangle. We are covering this triangle, okay? So this is line what? BC, okay? And we are covering this is BD over what? DC. Remember, in acceleration upwards, while in deceleration, the body decelerates or move what? Downwards. So we are looking at BD divided by what? DC. Is that clear? So if I draw this, show you the area we are considering. This is BC and what? D. And we're looking for A. The A here means deceleration or retardation. Okay? Now, you see the same thing that is applicable here. BD is vertical, and vertical means velocity. We come outside here to pick the value. Why this is 30 and this is what? 0 on the vertical, right? Then for the horizontal, this is 30 and this is 20. This is velocity, while this is change in time. Is that clear? Now, for us to substitute into what we have, we are looking for A. So acceleration and deceleration is the same. The only difference is deceleration is a negative of acceleration. It's going to have a negative sign, okay? And the negative sign is coming from the horizontal component side, which is the time axis. Okay, so if going by what we have, you can see that my BD here is 30 minus what? 0. So this is 30 minus 0 divided by what? My DC, I'm supposed to say CD, but because I'm going opposite of acceleration, so it becomes what? DC. So my DC becomes 20 minus 10. Sorry, 20 minus 30. So this is 20 minus 30, right? Now deceleration, A is equals to what? 30 minus 0 is what? 30 divided by 20 minus 30 is what? Minus 10. Is that okay? That is, we're going to cancel 0. So my deceleration becomes minus 3 meters per second square. Is that clear? Then, if you're looking at deceleration, we are covering this BC, line BC, right? And it's the distance between this AB divided AD divided by what? DC. Okay? So knowing that my AD, that is velocity axis, I will come outside here to pick the values of what I have, which is 30 minus what? 0. Okay? While for this here, I'm going to have 20 minus what? 30. To find the difference between them, you must get a negative sign because the body is decelerating. All right, so that is how we can solve this. Do you have any question with this? I want to go to the next one, which is the total distance traveled. All right, Christiana, should explain more. All right. Now, for us to this deceleration, like I explained earlier, that the body is what? This is deceleration. In this acceleration, the body was increasing. While deceleration, the body was what? Decreasing. So, as the body was decreasing, what you are going to note is the difference in the what? In the time, because it must have a negative sign. Here, the body decelerates to rest, goes down to 0, while this one accelerates from rest. You see the different things. So the body was decreasing here. So what we are going to do is to say the difference in the time must be this minus this. That is 20 minus 30. Why? Is because the body is decelerating to rest. Okay? And deceleration is a negative of acceleration. It's going to have a negative sign. And that negative sign is actually coming from the time axis, which is the horizontal. What I did was to say that this is BD. I brought out the triangle. This is BD, right? E minus what? 0. This is vertical. So if you make respect to vertical, you are going to come outside the velocity to pick the value. This is what? 30. While D here is what? 0. Okay? That is what I have by 30 minus what? 0. While D here becomes 20 minus my C becomes what? Minus 30. Okay? So by the time you subtract, what do you have? 30 minus 0 is 30. 20 minus 30 becomes minus 10. By the time you cancel, I'm going to have minus 3 meters per second square as my deceleration. I hope that is clear. All right. All right, so let's solve the next one. I'll soon end this class. Okay, the last one, which is the C part, we are asked to calculate the total distance covered throughout the motion. Total distance covered throughout the motion. So, how do we do that? Total distance covered throughout the motion. How do we do that? All right. We can actually solve this in two ways, by using a shape of a trapezium or by solving it differently one after the other. So what is the shape of a trapezium? I would say total distance covered is equals to area of trapezium. Do you understand? All right. It's area of trapezium. Now you're going to use the formula F. Remember, a type of a trapezium is what? Half brackets AB. I would say half basis times height. Half basis multiplied by height. The question is, which one is basis? Base means the horizontal AB. Another horizontal is what? OC. They are classified as bases, right? That is base. When they are two, they are bases. So this is half bracket AB from here to here, that is line AB, plus OC, line OC, then multiply by the height, which is what? Either use AE or we use what? BD. So I will use AE. Is that clear? Now, when I go into that, I will say half, what is my AB? Look at my AB, line AB, right? I will just come down here to find the difference between this. When you come down, you have it down at D and E, right? And this is 20 and 5. 20 minus 5. That is 15 plus, I hope you are clear. Now, OC, O and C, right? O and C. The difference between them, that is 30 minus what? 0. The difference between them is what? 30. Then multiply by AE. AE. Then come to this place, AE. This is 30 minus what? 0. Okay? To give us 30. Is that clear? Now, I have 15 plus 30. What do I have? We're going to have 45. This is 45. Multiply by 30, right? Now, I'm going to say 45 times 30 divided by what? 2. Of which 2 can divide itself, 1 can divide this, I have what? 15. So, to actually find out your answer, 15 minus 45, the answer becomes 675 meters. Is that clear? The answer becomes 675 meters. So let me do a recap. Okay, you're following what I just did. Let me see if I have a question before I reverse. Okay, Chimos, they are just joining us. All right, you said I should go back. All right, let me go back to what we have. Okay, how did I get 15? Okay. Yes, any other question? Okay, wait, are you still here? Okay. She said, how did I get 15? All right. Now I said have basis times height. Now the bases are, this is AB, AB, AB. That is, if I decide to draw this diagram, I'm going to have this. Is that clear? So this becomes A, B, C, and O. Is that clear? Now this is the height. This is the shape of a trapezium. So look at it. If I say half basis times height, my bases are the horizontal while my height is the vertical. Now this is AB. The first base is AB, right? AB, line AB. While the second base is line what? OC. Is that clear? All right. Now what's my line AB? I have a line here. I have 20 and what? And 5. Right? For you to know what this line stands for, you're going to come here and find the difference between them. That is 20 minus 5. It's going to give me 15. That's why I have 15 here. Is that clear? All right. Then OC, that is, here is 30 and here is 0. The difference is 30 minus what? 0 is going to give me 30. Right? That is how I got my OC as 30. My OC as 30. Then my AE becomes my height. My height, okay? That is 30 minus what? 0. 30 minus what? 0 to give me 30. Is that clear? So I'll say half bracket 15 plus 30, that is 45, multiplied by what? 30, right? Okay. Multiplied by 30 divided by what? 2. If 2 divide itself 1 and divide 30 to be 15, by the time you multiply, the answer becomes 675 meters. Is that clear? Right. Half. That is the formula of area of a trapezium, okay? We use the area of a trapezium to find the total distance traveled in velocity time graph. That is the formula, half base times height. But in mathematics, we normally use half AB times height. Half A plus B, sorry, times height. But in physics, we use half AB plus OC multiplied by height. Once you say number 1 was here since when? All right. Are we cleared? Do we still have question? Do we still have question? I want to end this class right now. Do we still have question that you don't understand? Christian, do we still have question? Prevail, do we still have question? All right. There is another way of solving this. I will teach you another way of solving this. That to get the total distance traveled. Okay. You can solve it in two ways. This is the first way. This is the first way we can solve it. We can solve it in two ways by saying that this is x1, x2, and x3, right? We are going to solve them separately and add them together. We are still going to get this distance to be what? 675 meters. So let's try it. You need to know the two methods. In case you're asked to calculate distance traveled after the first 5 seconds. So you don't need to use this formula to solve for all. Do you understand? Okay. Okay, let's solve. So for us to use the second method, the x1, this is a shape of what? A triangle. I will use area of what? Triangle, right? So, and the formula is half base multiplied by what? Height. Now, what's the base here? I can use this as the base, right? See, I'm considering this x1, that is this shape. This I'm considering alone. I want to solve it separately in case you're asked to find the distance covered after the first 5 seconds. So you don't need to use area of a trapezoid for all of them. You just use area of a triangle to solve. This is a triangle, this is a rectangle, this is a triangle. Solve all together and add them. You're going to get the total answer to be 675 meters. Okay? Now this is 30 and 0. Then also have, for the vertical, we also have 0 and 5. Change in V over change in T, right? Now I can say this is AE over what? EO. So what's my AE? 30 minus what? 0. Over EO is what? 5 minus 0. Right? No, there's a mix-up. I said half base times height. I just have to get the base and the height. Okay. Half base. What's my base? I can use this as base, which is what? Let me say half times. What's my base? My base is 5. My height is what? 30. Right? Then I can cancel this one. Cancel this. I have what? 15. So 15 times 5 is going to give me x1 to 75 meters. Do we understand? Should I go back? All right, I want to see your comments. Now, in the second one, which is S2. This is a rectangle. Look at the shape. A, B, D, and E, right? This is a rectangle. Now, the formula is length, right? So what's the length? Difference between this and this, 20 minus 5 is 15. So I have 15 multiplied by, then the breadth, 30 minus 5 is 30. Okay? So what do we have? Let's multiply. We have 30 multiplied by 15. The answer is 450. So I have 450 meters as S2, right? Then S3 is also the same thing as triangle, right? This is BD and what? C. And the formula for S3 is half base times height. So what's my base here? 30 minus 20, that is 10. What's my height? 30 minus 0, that is 30. Okay? Now this cancels to give me what? 5. So S3 is equals to 5 multiplied by 30. What do I have? I'm going to have 150. Okay? Is that okay? Now, for us to get the total distance traveled, that is x. Total is equal to x1 plus s2 plus s3. So what do we have? 75 plus 450 plus 150, right? So my total answer is going to give me 675 meters, which is the same thing as what you solved earlier. So what I'm trying to conclude is that if you're asked to find the distance covered from the first 5 seconds, you don't need to use the area of a trapezium to solve for this, because this is what they asked you to get. They asked you to find the distance traveled the next 15 seconds, that is from here to here, right? Okay, so you add this and add them together. Okay, but in this one, distance is from here to here, while this is from here to here, this is from here to here. This is a shape of a triangle, a rectangle, a triangle. By the time you sum them together, it's still going to give you the same thing as the shape of a trapezium. Am I cleared? Okay. Christian, say you don't understand. Where does you not understand? Where do you not understand? Let me go back, because our time is up. S2, okay? S2 is a rectangle, okay? This is the length. See the length. 20 minus 5, that is 15, okay? Then, I seen it. The breadth, I seen it, okay? Then I come here, 30 minus 0, that is what? 30. By the time I multiply, I will get what? 450 meters. Is that clear? Are we clear now? S1. S1 is area of a triangle, half base times height. Half base times height. Half, this is the base. This is the base. This and this is the base, y this is the height. Okay, now for the base, difference between here and here is what? 5 minus 0. When you're looking for distance, you're looking for difference. Difference between this and this, 5 minus 0 is 5, and the height is what? 30 minus 0 is what? 30. Do you understand? So this is half base. My base is 5. My height is what? 30. By the time I multiplied, I have this. Then 2 divide 30 to give me 15. 15 times 5 is 75 meters. Okay? All right, I hope you are cleared now. All right, we have come to the end of today's class. I hope you understand better. Like I always advise you, the more you read physics, the more you solve, the more you understand it better. I'm going to put up an assignment in the community post. Okay, so just go to my channel and check on the community post. You're going to see assignment I'm going to give you today. So work on it and send in your answer in the comment section. You're going to see, you're going to put your answer once you see the assignment. Is that okay? We are going to meet tomorrow same time to work on second term scheme of work. Is that okay? We're going to start the second term scheme of work. I'll see you next time in my next class. Bye.